so just a reminder, back to good old-fashioned right triangle trig. Looking at a right triangle with positive angles for the most part, unless we're dealing with different quadrants. But, so we're just going to be looking at, so we just looked at trig and extended it not only to right triangles in quadrant 1 that are positive angles, but to all these different types of angles. That's what the unit circle is useful for. It lets us find sine, cosine, tangent, and the other trig functions of anything that we know. Now, today we're doing our second look at the 6 trig functions, and we'll be looking at it from the right triangle perspective instead of the unit circle. So just a reminder, if you have a right triangle, and then let's say our angle down here, let's call that angle theta. Just a reminder, I'm sure you all know this, but theta is spelled like that, just a Greek symbol for angle, but just make sure you're saying it right, theta. All right, so given theta, this would be considered the opposite side. This would be considered adjacent, and across from the 90 degrees is always the hypotenuse, correct? And then we know our 6 trig functions of right triangles. Sine is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. So cosecant is the reciprocal, which is hypotenuse over opposite. Secant is the reciprocal of cosine. Hypotenuse over adjacent, and cotangent is the reciprocal of tangent, which is adjacent over opposite. Everybody knows those already, correct? Do I need to give you a second to continue writing those down before we move on? So it says, very easily, find the 6 trig functions. This is super easy. We're dealing with a right triangle. We have this side and we have this side, so it's pretty easy to find the hypotenuse in this one. So we just use, right, Pythagorean theorem, 3 squared, side 1 squared plus side 2 squared equals the hypotenuse squared. So 3 squared plus 4 squared equals hypotenuse squared, correct? 9 plus 16 equals hypotenuse squared. 25 equals hypotenuse squared. So hypotenuse is 5, correct? Everybody feeling good about that? Okay, so we know our hypotenuse is 5, and now let's answer those quickly. So sine of theta is opposite over hypotenuse, so that's 4/5. Let's just do cosecant while we're at it. So cosecant theta will be 5/4. Cosine of theta, oh heck, another hour, adjacent over hypotenuse, correct? 3/5. So secant is 5/3. And tangent is, oh heck, another hour of agony, opposite over adjacent, or SOHCAHTOA, however you remember it. Opposite over adjacent, 4/3, so cotangent of theta will be 3/4. That easy. That's going to be some of the problems that you're seeing. Pretty simple and straightforward, and that's all last year. Okay, now let's think a little bit further. So it says, let theta be an acute angle such that sine of theta is equal to 0.6. So we have all the information we need here. So it says let theta be an acute angle. Okay, so I'm going to draw a right triangle here. Theta, such that sine of theta is 0.6. Well, what is 0.6? We could change it, well, yeah, I mean, be honest, 0.6, let's change it to a fraction. Okay, 3/5. So actually, we're going to say sine of theta equals 3 over, you said 5th. 3/5, right? Okay, so sine is, you have to say to yourself, what does sine actually mean? Opposite over hypotenuse from theta. So go to theta, the opposite will be 3. The hypotenuse will be 5. So now we'll find the 6 other trig functions. So it just takes a little bit of thought. So then you'll do 5 squared minus 3 squared equals the other side squared, correct? Is that too quick, or do I need to show you why that is? Hypotenuse squared minus one of the sides will be the other side squared. Okay, so that's 25 minus 9 equals x squared, 16 equals x squared, x equals 4. Okay, so then sine theta, cosine theta, tangent theta. Do I need to keep going, or is that just overdoing it when you already know how to do that? Right? Okay, that's overdoing it. So, I'm not going to keep going. You're good. Let's move on. Okay, so it says, let theta be an acute angle such that tangent of theta equals 3. So how we're going to look at this one as is, isn't 3 technically 3 over 1? Okay. So we would say to ourselves, well, what is tangent? So tangent is, oh heck, another hour, opposite of agony, opposite over adjacent. So I'm going to draw a right triangle, put a theta. Opposite is 3 and adjacent is 1, correct? So now let's find, it says find sine and cosine, so let's do that. So here we go. So let's find our hypotenuse. So 1 squared plus 3 squared equals our hypotenuse squared. So that's 1 plus 9 equals our hypotenuse squared. Am I correct? Am I right or am I right? I'm right. Yep, 10 equals h squared. Sorry, I was just getting bored up here. Just trying to entertain myself. Okay, so square root of 10. Does that simplify? No. So there's square root of 10. So now we'll say sine of theta is opposite over hypotenuse, 3 over the square root of 10. Now I know you guys easily will look at that and say, that is not an appropriate answer because I can't have a radical in the bottom of a fraction. Now I know you guys are really good at rationalizing denominators. So you know that you multiply by that over that, right? So our answer will be 3 square roots of 10 over 10, and then 3 and 10 don't simplify. Cosine of theta is, oh heck, another hour, adjacent over hypotenuse, right? Which would rationalize to be the square root of 10 over 10, correct? Everybody feeling good about that? Okay. Me too. Given the cosine of theta, now this is throwing in another element here. Throwing in another element, which we can do that. It says, given that cosine of theta is negative 5/7, whose terminal side is in quadrant 3, find sine and tangent. So we've got to think about this a little bit. So we're dealing with quadrants, so we know it's somewhere in quadrant 3, correct? So quadrant 3 is over here. That's not going to be able to be possible. Yeah, this is going to be, I'm going to change this to be quadrant 2. I made this problem up and just didn't think about it good enough. So this is actually in quadrant 2. Nope, it's, let's do, yeah, quadrant 2. That's the only possibility here. Okay, so we're in quadrant 2. So we know it's somewhere in this quadrant. So we're going to have a right triangle over here. Oopsies. Okay, so now cosine of theta is adjacent, oh heck, another hour, correct? Adjacent over hypotenuse. So from theta, the adjacent side is? Negative 5. Now, why did you choose the negative to be at the 5, not the 7? Because isn't that in the negative x direction? Positive, so adjacent over hypotenuse, and so our hypotenuse is 7. Okay, so now it says find sine and tangent. So we would need to go through and find this side first. 7 squared minus negative 5 squared equals question mark squared. Are we all good? So that's 49 minus 25. 24 equals question mark squared. Now, the real question is would you guys recognize that when you take a square root and you get a decimal, it would be not acceptable? So let's break down the square root of 24. 6 times 4, 2 and 2. 3 and 2 won't pull out any groups of 2, so isn't this 2 square roots of 6? Okay, so 2 square roots of 6. You will see this on your ACT, by the way. 2 square roots of 6. So now we can easily find sine of theta is opposite over hypotenuse, so 2 square roots of 6 over 7. And tangent is opposite over adjacent, so 2 square roots of 6 over negative 5. It's that easy. Everybody feeling good about this? See, this day is easy compared to the other days we've done in this unit. Everybody good? Okay. Okay, given that cosecant is 17 over 4, find cosine theta, tangent theta. So first of all, just want you to think about the fact, if this, what is cosecant? It's the reciprocal of sine. So sine is opposite over hypotenuse. So this must be hypotenuse over opposite, correct? Yeah. Everybody good? So now if that's positive 17 and then opposite is 4, okay, so hypotenuse is going to be 17 and our opposite side from theta will be 4. So let's draw in 17. We don't even need to draw in standard position. Theta. So opposite would be 4, correct? Okay, so now we'll find the other side. But so do I need to keep going? Are we good with that? It's pretty easy, right? Now it's just recognizing this. Everybody good? Okay. Okay. Would you know how to do this one? Let's see if you can do it. How about let's see if you can think. I'm not going to just tell you how to do it. Let's see if you can do it. Given the point on a circle is at -6, -3, find the 6 trig functions, go. Looks like we've got it. So you went back 6, -3, plotted that point. You found the hypotenuse and it was 3 square roots of 5. And we called this theta. So sine of theta was opposite over hypotenuse. So -3 over 3 square roots of 5. Those divide out. So we have -1 over the square root of 5. So we rationalize it. Square root of 5, square root of 5. So we have negative square root of 5 over 5. And then that continues, and I'm not going to continue onward. You should be able to finish the rest without me going through it. Does everybody see how I just drew where it was? I literally plotted those points, and then I knew where to go. Yeah. Yeah, we're going to draw it down here so we're doing the right triangle. Oh.
Because the length would be the same, but then it would just be different, how do you know that?
Oh, you're saying like if we drew this over like this, and then put theta down here?
No,
oh. Yeah, theta you'll always put up here. That's actually a good question. I haven't thought about why. What do you mean? Cosine is adjacent over hypotenuse. -6. Yes, you can. Yes, silly. Negative. Yes, you can. What's 6 and 3 divide out to be? Good. 1 over 2. So you'd say my answer is -2 over the square root of 5. Is that an acceptable answer? So we rationalize, right? I'm glad you asked. -2 square roots of 5 over 5. Yeah, good question. So yeah, we will always draw theta up here. That's a good question. So yeah. Okay. All right. So number 60 out of the book. Now let's keep going here. It says solve for missing angles and missing side lengths of the triangle. So now everybody watch, because this is going back to secondary too. It's very easy, but you've got to be really good at your algebra and not do weird things. So everybody have your calculator out. Here we go. So it says solve for y. So looking at this picture, if this is 60 degrees, this is the easiest to just use right triangle trick. This is my angle theta. What side do I have? Opposite and hypotenuse. Does everybody see how from theta I have opposite and hypotenuse? So which trig function should I be using? Sine is So am I making sense though? Sine is opposite over hypotenuse. So look, sine of theta equals opposite over hypotenuse. Now let's plug in what we know. Sine of what is theta? 60 degrees. And then what is opposite? Y. What's hypotenuse? Now solve for y using algebra. What will we do to get y alone? Multiply by 18, right guys? So here's what you'll ask yourself. That's a great question. That's what I was going to talk about next. Now look, isn't y alone? So we're done, right?
Yeah.
Here's what you'll do. So and actually interesting enough on the ACTs, a lot of times I see them leave it like this. Like this is the answer. But we want you to actually calculate this. So isn't this in degrees? We're plugging in degrees. So our calculator needs to be in degree mode. 15.5. This is wrong. We gotta stop. We need exact answers. We don't want decimal answers. That's secondary 2 level. So now that we're at secondary 3, like you literally will not be able to use a calculator during this portion of the test. I have calculator portion, non-calculator. So what would we do? What is the exact value of sine of 60 degrees? Go to your unit circle, everybody. Go to 60 degrees. Sine is? Don't guess. Use your unit circles. No, that's 60 degrees, guys. Sine of 60 degrees. How do we find that? Go to 60 degrees, find the y coordinate, which is? Okay, so this is really y is equal to, we have 18 times the sine of 60 is the root 3 over 2. So my only correct answer is, what's 18 divided by 2? 9 square roots of 3. Everybody feeling good? Okay, you won't be able to use a calculator in this portion of the test. You really won't. Okay, let's do another one. Numbers. Okay, let's do 62. Everybody watching. So it says solve for R. So, solve for R. So we would set up a true statement. Once again, this one's too easy because it's the same thing. It's opposite and hypotenuse, so it's sine again, correct? Yeah. So this one's too easy. So sine of theta equals opposite over hypotenuse. Put in what you know. Sine of 45 degrees equals opposite, which is 20, over hypotenuse, which is R. Now, careful here. Don't just say, I'm always going to do the same thing. Algebra is different for every single problem. We're trying to get R alone. What are we going to do first? If you divide by 20, you are not wrong, but I would do something first. No, good thought, but if you did sine inverse, that would undo sine and leave us with a floating 45 degrees. Good thought. No, guys, no. Algebra to get R alone. Get R alone. No. Wait, when you say inverse to me, you mean reciprocal. Okay, sorry, there's a difference. So, no, sorry. Everybody, let's just do algebra to get R alone. Here we go. Ready? Multiply both sides by R. Okay, we're trying to get R alone. So right now we have R times the sine of 45 degrees equals 20. What's my next step to get R alone? Divide by sine of 45. That's where Amelia was going with this. Divide by sine of 45 degrees. But here's why. We just use algebra to get R alone. Does everybody understand? That's where you were going with this. Yep. Okay, yeah, cosecant. Yeah. Okay, good. So, yeah, because you're right. That's the same thing, right? Same thing. You're right. Very good. Okay, so guys, finish that one off for me. Exact answer, you don't get a calculator. It's in sine of 45 degrees, root of 2 over 2. Dividing fractions is easy as pi, so that's 20 over 1. We flip the second, and we multiply. Isn't that 20 over 1 technically? We've got to get really good at thinking of things like this. Divided by, so that's 20 over 1 times by 2 over root 2, correct? So that's 40 over root 2, which is not an acceptable answer. We would rationalize the denominator at this point. Root 2, so on top we have 40 root 2, and on bottom we have a 2. So now 40 and 2 simplify to be 20 root 2. That would be the only acceptable answer. You've got to use your unit circle, yes. Perfect, yep, or yes, absolutely. That would have been easier than even right triangle trig, correct? Everybody's saying that we know the relationship of a 45, 45, 90. Yep, so we know that the hypotenuse would be that side, root 2. Very good, yep. There are right ways and there are long ways. As long as your math comes out right, it doesn't matter how you get there. Yeah, and does it make sense? Like we know at 45, if this is 20, this is 20, right? And then this will be 20 square roots of 2. So yeah, but we just did it the hard way, which is fine because our math came out the same. Using the relationship of 45, 45, 90 degree triangles. Well, if this is 45 degrees, then we know it's 20. Won't this side also be 20? This squared plus this squared equals this squared? Hey, are you listening though? I feel like half the time you guys ask questions right here and then you don't actually listen. He was trying to explain and that was good. So, oh, no, yeah, but I'm just saying, like, half the time I feel like you guys ask and then I answer and you really don't listen. Okay, so I'll answer it, because you guys ask great questions, but then I answer them and everybody else wants from them but you. Okay, so, no, really, you guys ask really good questions and I always answer them and you're zoned out. So watch. We knew this side was 20. It's across, are you watching? See here, we're doing it again. If this is 45 degrees and that side's 20, then if this is 45 degrees, this side will be 20. Yeah. We didn't know hypotenuse, correct? So we did 20 squared plus 20 squared equals hypotenuse squared. Then we would go through and find the square root and simplify it to be that. Pythagorean theorem. Yes. We're not going to. Okay, angle of elevation. Okay, the bell's going to ring in a few seconds, so everybody should just be able to do this easily. Watch. Angle of elevation is a word you need to know. Angle of elevation, you've got to memorize this. It's created from the ground looking up. Ding, ding, that creates an angle of elevation. So the angle of elevation from this person up to the top of the tree is the angle from the ground up. Everybody good? Angle of depression, people get confused. They'll think it's this angle down here. So this is a bat. A bat, can't you tell? And a person getting attacked by a bat. The angle of elevation to the person is this angle up here. A lot of people will, because we'll have a right triangle. Do you see the right triangle here? A lot of people will do that as angle of elevation, which that's not. The angle of elevation is from up to looking down. So that would create this angle. So don't we know that alternate interior angles are equal? So won't this angle be this angle the same? So isn't the angle of elevation also the angle of depression? Yes. Okay, awesome. Everybody good? Oh, look how easy this one is. It says, what is the angle of elevation to the top of the building if a man walks 50 feet away from a 300-foot building? So I drew the picture, and then angle of elevation from the ground up. Now, if I would have said, if a person is looking out, what's the angle of depression? That would have been the angle of elevation. Does everybody understand the difference? Same thing, right? Yeah. Okay, so then we would do opposite and adjacent. Which one has opposite and adjacent? Tangent. So we're going to be using tangent of theta equals opposite over adjacent. Put in what we know. Tangent of theta, we don't know theta. Opposite is 300 over adjacent, which is 50. Now this is where we need to get theta alone, correct? How do you undo tangent? Inverse tangent. Very good. So we need to undo tangent. The only way to undo tangent is to apply the inverse. So we do tangent inverse, because you got to do it to both sides of the equation. Inverse tangent and tangent cancel out. That's what inverses do, is undo each other. So we have theta is equal to the tangent inverse of that side. Okay, whatever, yeah. But you're good too. So type it in. What do we get? Now we are typing in, so you'll need it to be in degrees. 80.5 degrees is the angle of elevation. Everybody good? Oh my heck, we're awesome. You're writing them down. I'm just going to explain what they are. So, trig identities are just things that are equal to something. So, you can rewrite sine as 1 over cosecant. You could rewrite cosine as 1 over secant. You could rewrite tangent as sine over cosine. Same thing. Or vice versa. So, either way. Cosecant of theta is 1 over sine. Secant theta is 1 over cosine. Cotangent is cosine over sine. So you could, anytime you see cotangent, you could rewrite it as cosine over sine. Or anytime you see cosine over sine, you could rewrite it as cotangent. Then some new things here is sine squared theta plus cosine squared theta equals 1. That is a true statement. Then also 1 plus tangent squared theta equals secant squared theta. And then 1 plus cotangent squared theta equals cosecant squared theta. So if you see any of these, you can rewrite it from one side of the equation to the other. You can rewrite it both ways. However will help you, if that makes sense. So you're going to see what we're doing with this in a second. Get those down and then we'll start. Now I want to point out something really interesting here. If we know this trig identity, watch what happens. You're going to see this, and I can't even tell you. You will see this so much in calculus, guys. You will take, if you see this, can't we get cosine squared of theta alone by subtracting sine squared theta? Watch. Subtracting sine squared theta. So isn't another, hey, you guys over there are not listening. So you're going to be confused. Do you see what I'm saying? So a trig identity, cosine squared theta is the same thing as 1 minus sine squared theta. Does everybody see? And vice versa. Okay, here we go. Keep those in front of you. I'm going to keep them in front of me. I refer back to them all the time. Here we go. So, number 34. This is the same as the one on your homework. You might want to write this down and so that you can see my logic here. Or just watch. It's up to you. So it says, use trig identities to transform the right side of the equation to the left side of the equation using trig identities. So basically they're telling us this side is going to be equal to 1. Show me algebraically how we got there. So what you're going to do is focus on this side and go through and start simplifying it using trig identities. So this one's easy. These ones are too easy. I did harder ones with my secondary 3 regular students last year. But that was at the end of the year. Anyways, good practice to start us out. Cosine of theta, okay, I'm going to just stick with cosine of theta for a second. And then secant theta. Secant, I mean, usually this is how I think through it. I usually like things in sine, cosine, tangent if possible. Does that make sense? So that's why I decided to leave cosine as cosine. Does everybody understand? Okay, what is secant the same thing as? So we have here cosine of theta times 1 over cosine of theta. So this one's just way too easy. So now we see that cosine of theta times 1 over cosine of theta is the same thing as cosine theta divided by cosine theta, correct? What part is? Okay. So then, what is cosine over cosine, guys? 1. So check, check. We got there. Showing all the work. See how easy that one was? These aren't even hard ones. Yeah. No, we're just showing that. We're not solving yet. We're just showing why they're equal. Okay, so number 36, cotangent theta sine theta equals cosine theta. So I'm going to go with this side. Now, once again, I usually like, this is how I know where to start and kind of go from there. There's only a few times I change sign, but I usually like it in terms of sine, cosine, tangent. So what is cotangent the same thing as? We could do 1 over tangent. That is totally fine. That's totally fine, but that will be a lot more algebra. Isn't cotangent the same thing as cosine over sine? So what we really have is for this piece, we have cosine theta divided by sine of theta. And then we're multiplying by sine of theta. Now just stick to that side of the equation. So now we know that that's cosine theta, sine theta, correct? We multiply straight across, divided by sine of theta. So we're showing in our work. So then sines divide out and we get cosine theta. Check, 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 check. It's all golden. These are such easy ones. I want them to be much harder. Now, this is why this is useful. You will get in calculus at times something like this, and they'll say find the integral or do something like that. And then you're going to be like, what the heck do? I don't want to have to do parts integration by, anyways, this would be a mess. So you would figure out, oh, that's the same thing as cosine, so we're just going with one thing. Even Trevor looked back here, he's in calculus, he's a smart kid back there. He said yes, he has already seen some of this stuff, so I'm not just BSing you. 38, here we go. Let's go through it. Oh, a little bit more tricky. Because it's just like, where do I start sometimes with these? Because I even on this one, because last night I was like, I'm going to make sure that I know, I can do all, even if I couldn't, I could figure it out somehow. But I'm like, I'm going to go through these. So I sat down and I started doing this one way, and it got messy, and I'm like, I must be tackling this the wrong way. Not that I would have been wrong in the end, my algebra would have been the end, but I was like, there's no way this one's as hard as I'm making it out to be. So first of all, looking at this one, look at your trig identities. Nothing equals just 1 plus sine of theta. They're all squares, correct? Look at your trig identities. Okay, so I would distribute it, yes. Notice they're conjugates, correct? 1 times 1 is 1. 1 minus sine of theta is negative sine of theta. I'm going to show my work. Plus positive sine of theta times 1 is plus sine of theta. And then we're going to have positive sine of theta times negative sine of theta, which is negative sine squared theta. So now our middle terms cancel out, so we have 1 minus sine squared theta. That's all just the right side. Now look at your trig identities. Yes, perfect. So we know that cosine squared theta plus sine squared theta equals 1, correct? So let's get sine squared theta, let's get cosine squared theta alone. So we'll subtract sine squared theta. So we'll have 1 minus sine squared theta equals cosine squared theta. So boom, boom, boom. There's cosine squared theta, and then we'd say, oh, check, check, check. We got there. Yeah, as long as you know where to start, kind of. So we are using this trig identity. So then we solve for cosine squared theta by subtracting sine squared theta. So we know 1 minus sine squared theta equals cosine squared. Okay? Well, no, we were trying to prove that this side equals this side. So we focused on this side, simplified down until we got to the right side. So then we said they're the same. So we're done. We proved it using algebra. Good? We were going through and trying to figure out how they were saying this was equal to cosine squared theta. So we focused on the right side and got the same thing. So then we knew we were done. So we proved it using algebra. Does that make sense? Okay, last one. Almost last one. Here we go. Sine squared theta minus cosine squared theta equals 2 sine squared theta minus 1. This is problem 40 out of the book. Let's see if we can think of how we should go from here. Look at your trig identities. Isn't this number 40 in the book? No, that's not this what's in the book, is it? So, this one I'm honestly not quite sure where they're going from here. So let's just see if we can think about it. Sine squared theta minus cosine squared theta. That's not a trig identity. Well, what they want us to do is take this side of the equation and prove it's equal to this side. So let's see, where should we go from here? You would what? She was saying that same thing. But remember that we're trying to go from, you guys are on the right track. Remember that we're trying to go from this side over? Okay, you do? Can you tell me where we should start out here?
We should start by subtracting sine squared theta from both sides and adding 1. And then add cosine squared theta with 1 from sine squared theta plus cosine squared theta.
I have a totally different problem written down for 40 in my paper. Is this, you looked in the book?
Yeah.
Here's the thing, Amelia, I see what you're saying, but what you're doing is you're using this side. In the instructions, I'm not sure that's okay. Because they said, use trig identities to transform the right side of an equation to the left side. Oh, so we're going this way. Right side over this way. Yeah, I'm trying to think if that would be. I'm just trying to go with the instructions. There's not a reason. Yeah. Okay, so let's just, we could just go with it. Right. I see what you're saying. So we could, yeah, I was just thinking that we had to do it without touching the other side of the equation, but maybe the instructions are misleading. Does that make sense?
I do remember.
Well, any instructions were just like literally switching. Just a sec. I did a different problem, so that's why. Huh. I don't want to waste 42 though. Okay, let's do 42. I would watch this one. So we have, it says what? Yeah, from the left side. See, I just don't think we're supposed to use.
Yeah, I see what you mean.
Yeah.
Like,
But we haven't had to in any of those. I feel like we should be able to go through it. It just takes some thinking. Yes.
For one sine squared theta plus cosine squared theta.
That's where we're going with that. Okay, that's where we're going with that. Yeah, I was gonna say I don't think we're supposed to use both sides to, but I see. Okay, awesome, good. You're right. So you're saying let's go from this side over this way. So I see. So good. They just thought of something. See, they just take some thinking. Very good. So they said 2 sine squared theta minus 1 is the same thing as 2 sine squared theta. What's the same thing as 1? That's exactly where they're going with this. Very good. Way to think of that. What is 1 equal to? Sine squared theta plus cosine squared theta. Is that true?
Yeah.
Okay, isn't that a true statement? So there it is. We have, now we'll distribute our negative through. So we have 2 sine squared thetas. Very good, guys, back over there. That's awesome. And then we have minus 1 sine squared theta. And then we have minus 1 cosine squared theta. The reason I'm writing in those ones is to remind you of what we can do here. 2 apples minus 1 apple is how many apples? Okay, so 2 sine squared theta minus 1 sine squared theta is how many sine squared thetas? So we have 1 sine squared theta, and then we have minus cosine squared theta, and now we have arrived at this side. Very good, ladies and gentlemen over there. Okay, great. Awesome, see? You guys are great. Okay, let's do this next last one, and then I'll give you the rest of the time, so everybody watching, so that you can make sure you can do it. So we have tangent theta plus cotangent of theta all over tangent of theta. Now understand there's a lot of different ways we could tackle this problem. So my way might not be the same as the way you choose to do it. How I chose to do this one was split it up. I rewrote this one as tangent of theta divided by tangent of theta plus cotangent of theta divided by tangent of theta. Does everybody see how I left it? It's the same thing, right? I just split it up. So isn't that 1 plus cotangent of theta over tangent of theta? Okay? Now we really have, if you think about what we really have here, we have 1 plus, what is cotangent? Okay, you can think of it a few different ways. Cosine theta over sine theta, right? And then divided by tangent of theta, there's different ways of thinking about this. So tangent is sine of theta divided by cosine theta, right? Okay, that's one way of thinking about it. So dividing fractions is easy as pie. Flip the second fraction and multiply. It's not a bad way. I like it. Okay, so now we're looking at this. We're looking at 1 plus cosine squared theta, correct?
Yeah.
Over sine squared theta. True? Which, what is cosine over sine? Cotangent, right? So we really have, where are we trying to get? I gotta remember, so I can see where we should go with this. Cosecant for theta. Have I made any errors anywhere? Nope. So isn't this, No. Just because we don't get it right off doesn't mean we should stop. So, I already did this one, but I don't want to look at my work, so I did it yesterday. There it is. This is the same thing as, so I'm looking at my trig identities, not my work. Isn't this the same thing as 1 plus, what? Cotangent squared theta, which is a trig identity, which is cosecant squared theta, and we've arrived. Yes? Yeah, there's a ton of different ways algebraically to go about this. So as long as you arrive there, you could, like I said, there was times last year when I'd go do it with one student and we'd get through it really quick and then I'd go over and have forgotten because I never, you know what I mean? I don't memorize anything or like there's no process, they're different. So all of a sudden I'd be going with a different student and I'm like, I know this problem shouldn't be taking us a page and a half. So does that make sense? You're right. There's other ways we could have arrived here. Does that make sense, everybody? Awesome. So I'm glad you guys are seeing that there's many other ways. As long as your algebra's right and your trig identities are right, you could arrive to this answer a few different ways. This is the homework. You should get started on it now. I don't want you wasting the time that I give you.